Laser light sails are the only chance of interstellar travel in our lifetimes. And I know, it seems like it's never gonna happen, like it's a sci-fi pipe dream. Mega lasers yeeting ships to relativistic speeds. But the simple fact is that we can make it right now with current technology, and they keep doing incredible research with no showstoppers, and it unlocks so many other benefits for mankind other than just interstellar flight. So why the haven't we started building it? Well, money, mostly. But it's so misunderstood that even when it's depicted in sci-fi, it's usually not done right. So let's take a look at what light sails are, some realistic paths forward, and the insane future of space travel that it could bring. So what are light sails exactly? Light sails, as their name implies, use light as propulsion, and light is made up of particles called photons. And even though photons have no mass, when they hit something, they impart a small force. Because of confusing relativistic timey-wimey reasons that I'm not going to get into. Solar sails use the naturally occurring photons coming from the sun, but even though the sun emits a ton of photonic radiation, it's not focused and it's a wide spectrum of wavelengths, and because of the inverse square law, diminishes rapidly with distance. Light sails, on the other hand, use laser light, which is focused or collimated so that all of the photons are traveling parallel and are of the same wavelength. They refer to this as directed energy. Technically, anything that uses photons for propulsion is a light sail, so a solar sail is a light sail, but scientists tend to refer to laser-pushed light sails as just light sails, although there are exceptions. But why light sails? Rapid and fully reusable rockets are the first step out of the gravity well, but if we want to go any further, we have to move beyond chemical rockets.
Newton's third law. The only way humans have ever figured out of getting somewhere is to leave something behind.
Except that's not true with light sails. Light sails are special because they are not rockets, and therefore they are not subject to the tyranny of the rocket equation. Which just means that rockets don't scale linearly. They have diminishing returns. You can't just keep adding fuel and engines. Light sails flip this and leave the rocket at home, which frees it from tyranny. The only limiting factors are how much photonic energy you can throw at your sail and how big and lightweight you can make that sail to withstand that energy. And up until recently, this would have meant building one giant mega death laser, which would be impossible to build, and blasting it at a sail which could not handle the energy. But in just the past few decades, advances in phased arrays, solid-state lasers, and material sciences have moved it into the category of actually possible, which means that you can now use thousands or even millions of small lasers combined into one, mega death laser. Which might actually be one of the reasons why we haven't started building it. It's literally a Death Star. Anyone who controls a laser of that size can reach out and touch anything. And NASA doesn't want to cross that line. According to Donald Kessler himself, yeah, that Kessler, NASA's unofficial line is that any laser proposal is dead on arrival. But we don't need NASA's permission anymore, Dad. We're in the midst of a private space industry revolution. For way less than the cost of just one SLS rocket, we could build a 150 kilowatt laser broom. A laser broom can change the orbit of space debris or delete it entirely, depending on the material and the size of the object, and would be cost competitive with any other type of space debris mitigation. A 50 megawatt array would be capable of deflecting an asteroid on collision with Earth. This is what was suggested by the aptly named D-STAR program from the Experimental Astrophysics Group at UC Santa Barbara. By the way, thanks to the phased arrays that I mentioned earlier, you don't need those fancy gimbaled lasers from the intro of this video that I spent a week making. You just need a fixed array like this, and the phase can be altered for precision targeting. Also, just for visualization purposes, 50 megawatts of solar is roughly 50 square kilometers, and in combination with batteries and/or capacitors could be a plausible renewable power solution. But in order to send something to another star, we will need hundreds of gigawatts. And solar probably wouldn't fit the bill because it would take a solar farm the size of Nebraska. The current plans of the Breakthrough Starshot Initiative, as of 2021 at least, call for 200 gigawatts powering a 2.8 kilometer wide array, which would accelerate dozens of 2-meter wide craft that weigh only a few grams up to about 25% of the speed of light in under 20 minutes and reach Proxima Centauri in only 20 years. By the way, the current research suggests that using this parabola shape is ideal to help with self-navigation. And probably in real life they would avoid the moon due to, gravity issues. Because one of the many hurdles is being able to accurately intercept a, relatively speaking, infinitesimally small moving target 4 light years away.
It's like trying to hit a bullet with a smaller bullet whilst wearing a blindfold, riding a horse.
And the sail needs to weigh less than a gram, but have a material that can withstand 200 gigawatts of laser energy. We also have to find a way to transmit images from these tiny gram-scale craft back 4 light years to Earth. And I'm really glossing over a lot of complicated engineering challenges, but the smartest people in the world are working on this, and they keep saying, looks good. Honestly, really the main showstopper is finding someone to foot the bill, because as of the making of this video, Starshot has been privately funded for about $100 million, but the end cost is estimated to be over $20 billion. Who's got hundreds of billions of dollars laying around and a track record of making unilateral mega projects? Maybe that's just the kick in the pants that we need to get a new space race going. With competing 200 gigawatt arrays, ships with humans could be pushed to Mars and slowed down with ion or nuclear engines in less than 30 days. And once you build a laser at both ends, you can go even faster. Earth to Mars in 7 days. Not to mention, it would open up the rest of the solar system to send probes faster and cheaper than ever before. We could intercept interstellar objects like a Oumuamua instead of just watching them fly by while we think about putting our pants on. But in order to send humans to the stars, we've got to think even bigger. And ideally have a way to stop and maybe come home. Enter Robert L. Forward's Prometheus. Robert L. Forward was one of the grandfathers of light sail technology, and he proposed a 3-stage, 1,000-kilometer wide ship capable of a round trip to any star within 10 light years in a human lifetime. But a ship of that size would need upwards of 40 terawatts of power. There's only one practical place to get that kind of energy: the sun. He proposed 1,000 solar-pumped lasers would be constructed in orbit around Mercury. Mercury would provide both the material to construct and also the gravity to keep the lasers in position. They would funnel that light into another gigantic 10,000-kilometer plastic Fresnel lens past the orbit of Saturn, which then propels the ship. When the ship is nearing its destination, the outer stage separates, the inner stage flips, and it redirects the light backwards, slowing the ship down, as the first stage goes on forever. Once the mission is accomplished, the ship separates once again, flipping and bouncing that light once again, and returning home from the second stage reflection. Yeah, I know. The material sciences and strength needed to make a sail this big are not within our ability to make right now. By the time a mega project like this is able to be produced, it's probably at least 200 years in the future, and antimatter may be a viable solution, and there are a lot of wacky ideas once you get out into the hypothetical level of technology. But the foundational technology of light sails is real. The most important photo in the history of mankind was taken from the moon in 1968. It was called Earthrise. It changed millions of people's perspectives of our lives on spaceship Earth, started an environmental movement, and the astronaut who took it said, "We set out to explore the moon, but instead discovered the Earth." Just imagine the impact of the new most important photo ever taken. The first image of another planet orbiting a different star, and possibly with life. I think we'll say we set out to explore new stars and instead discovered ourselves. When I was writing this video, I was depressed by the negativity. Everybody says it's impossible. The futility of opinions against interstellar travel and the future in general. And the real likelihood is that we may be in for dark times, but we definitely won't survive if we give up. I suffer from depression, so I know it's not always possible just to make a choice. But it kind of is. We gotta keep trying, like when we can. To set the goal of being constructive, positive, even when we feel like shit and the world is crumbling around us. To look for the pathways in the direction of hope. And for me, that's space. And what's the line from Contact?
I've always believed that the world is what we make of it.
Please leave a positive comment. Tell me how excited you are for the future of space travel, what it means to you, how we're pushing the boundaries to a new level. There's a saying that man's reach should exceed his grasp, and I think it's time to grab it. Thanks for watching.